In this class, now I am going to give you the complete concept of straight lines from coordinate geometry. Before going to start this class, now I am requesting you to subscribe, like and share my channel so that my classes reaches to many people. Now let us go to the class. You know students, standard form of a straight line is ax plus by plus c equal to 0, where a comma b comma c belongs to real numbers and simultaneously a and b should not be equal to 0. What is the meaning of this? Simultaneously a and b should not be equal to 0. Either a can be 0 or b can be 0, but both of them at a time should not be equal to 0. If you draw the graph of this, you get a straight line. So that straight line is neither parallel to the x-axis nor parallel to the y-axis. So you get a straight line like this. So take any one point on the line as x comma y, locus point, variable point. Now multiply this first component, second component with a and b and add some constant so that this result would be 0. It is a variable point, locus point. You can take anywhere. So on the line there are infinitely many points. Take any point and multiply first component with a real number a, second component with a real number b and add some constant so that that result would be 0. You know students, how to draw the graph of this? You learned. If you draw the graph of this, you get a straight line which is neither parallel to the x-axis nor parallel to the y-axis. Suppose if any one of a and b is 0, then how do you get whose equation? If a and b both are not equal to 0, then you get a straight line that is neither parallel to the x-axis nor parallel to the y-axis, which means that you may get that line. So on the coordinate plane, either like this or like this or like this or like this, you may get, however, but neither parallel to the x-axis nor parallel to the y-axis. Suppose if a is equal to 0, then that line will become by plus c equal to 0. If you draw the graph of this, you get a horizontal line. That line will be horizontal, parallel to the x-axis. Either you get like this or like this. If c is 0, then you get equation of y-axis as, equation of x-axis as y equal to 0. So in which suppose b is 0, a is not equal to 0, then you get ax plus c equal to 0. Now if you draw the graph of this, you get a vertical line. So that would be parallel to the y-axis. If it is c is 0, then that represents equation of y-axis. You know, on the y-axis, x coordinate of every point is 0, hence equation of y-axis is x equal to 0. On the x-axis, y coordinate of every point is 0, hence the equation of x-axis is y equal to 0. So suppose c is 0, then that line equation will become ax plus by, which is equal to 0. Then that line passes through the origin. You get like this. Otherwise, you may get like this. If c is 0, c means constant in the given equation. So this is the standard form of a straight line equation. Now let us go to the slope of a straight line. Slope concept. Slope of a straight line. You know, students, before defining the slope of a straight line, you would have to know the meaning of an inclination. What you have to know? Meaning of an inclination. So this is a one line. It is making certain angle with positive direction of x-axis in an anti-clockwise direction. That is called an inclination. Angle made by the line with positive direction of x-axis in an anti-clockwise direction is known as inclination of the straight line. So this line is making angle with x-axis in this direction and in this direction, but we want positive direction of x-axis. So this is a positive direction, this is negative direction of x-axis. So this amount of rotation is known as an inclination. Angle made by the line with positive direction of x-axis in an anti-clockwise direction is known as inclination. So this inclination belongs to either 0 or smaller than 180 degrees, but not exactly 180. Okay, students? So keep this line here itself, and about this point rotate like this. So up to smaller than 180 you can rotate. If it is 180 or more than 180, again, so this vertical angle will be equal, no? So same angle you will get. Hence, this is the interval for inclination. I hope you have got the meaning of an inclination. Angle made by the line with positive direction of x-axis in an anti-clockwise direction is known as an inclination. If you define this inclination with respect to tangent ratio, then you get slope of that line. So already this slope concept class already I taught. So that video is there in my channel. If you want more clarity, then you can go through that class. So in the short manner, I would like to revise this entire chapter. Okay, students. So what you require, so those things only I am going to discuss with you in this class. So I think you got the meaning of an inclination. So with respect to that inclination, if you define tangent ratio, then you get slope of the straight line. So if you open the books, you will get the definition like this. Tangent inclination of a straight line is called slope. So the slope of the straight line belongs to a real number, because the range of tan theta is a set of real numbers, no? So if the inclination is acute 0 to 90, so you get the diagram like this, then slope is positive. M is positive. 0 to slope is positive. If theta is 0 to 90 degrees. If theta is more than 90, you get the diagram like this. You get the diagram like this. So in this case, your inclination is more than 90. So more than 90, so hence your tan of an obtuse angle is negative, no? So that M is a negative, M less than 0. If theta belongs to 90 to 180 degrees. I hope you have understood this. See, one line equation will be given to you and they will ask us to find whose slope. But before that, so if any 2 points on the line are given, what is the slope of that line? You know, 2 points on the line are given, like x1, y1 is 1 point, other point x2, y2. Then whose slope will be y2 minus y1 by x2 minus x1. Okay, students? Right. Now, suppose if the line equation is given, ax plus by plus c equal to 0. Now, what is the slope of this line? If it is given, then what you people have to say? Minus a by b, where a is the coefficient of x, b is the coefficient of y. Right. Now what is the slope of x-axis? Slope of x-axis is 0, because if that line coincides with x-axis, theta will be 0. Then tan 0, 0. What is the slope of y-axis? So if you draw a vertical line which makes 90 degrees angle with x-axis, hence inclination is 90, tan 90 is not defined. Hence slope of the vertical line not defined. Okay students? Right. Next, slopes of parallel lines which are neither parallel to x-axis nor parallel to y-axis. If two lines are parallel, then which makes same inclination with x-axis, hence whose slopes will be equal. Inclinations are same now, hence slopes would be same. So if the slopes of parallel lines are equal, how that lines should be? Need not be vertical. If the which are vertical, then whose slopes will not be defined. Okay students? Right. Next, slopes of parallel lines are equal, but that lines should not be vertical. That those lines can be horizontal, because slope of an horizontal line, slope of the horizontal line is 0. So if any lines are parallel to x-axis, then whose slopes will be equal to 0. So slopes of vertical lines not defined. Remember this point. So if any two lines are intersecting 90 degrees to each other, then product of their slopes which becomes minus 1. One line is moving like this, one more line is moving like this. The two lines neither parallel to x-axis nor parallel to y-axis. Then product of their slopes, slope of this line is m1, slope of this line is m2. Then product of their slopes m1 into m2, which is equal to minus 1. Remember this point also. Suppose if any two lines are given like this, a1x plus b1y plus c1 equal to 0, and a2x plus b2y plus c2 equal to 0. If these two are parallel, hence as we know whose slopes are equal. Now we equate their slopes, a1 minus a1 by b1 which is equal to minus a2 by b2. Minus minus cancel. Now a1 b2 which is equal to a2 b1. This is the condition to become these two lines are parallel. Okay students? So how I got this? By equating their slopes. Now suppose if these two lines are perpendicular to each other, this is the symbol of perpendicularity. So as we know, whenever their slopes lines are perpendicular, as we studied, product of their slopes is equal to minus 1. Now what is the slope of this line? Minus a1 by b1. What is the slope of second line? Minus a2 by b2, which is equal to minus 1. Minus into minus plus. Now take their product. a1 a2, when it goes to the right side, minus b1 b2. When you bring both of this one to the left side, you get a1 a2 plus b1 b2, which is equal to 0. So this is the required condition to become these two lines are perpendicular. Okay students? Right. Next, now I am moving into various forms of straight lines. Various forms of equations of straight lines. Equations of straight lines. In this, first I would like to tell you gradient form of a straight line. Gradient form. Gradient form is which passes through the origin. that also can be called as slope form of a straight line. See, this is an origin. See, equation of a line passes through origin will be in this form, y equal to mx, where m is the slope of the straight line. If it is positive, then it passes through first and third quadrant. If it is negative, it passes through second and fourth quadrant. Remember that. This is known as gradient form or slope form. So the synonym of slope is gradient. Hence it can be called as slope form of a straight line or gradient form of a straight line. Next, slope and y-intercept form of a straight line. Slope and y-intercept form of a straight line. One line is moving like this, which is having slope m and making c units y-intercept. Hence this point coordinates 0, c. Then equation of this line is y equal to mx plus c, where c is the y-intercept made by this line, means this distance. M is the slope of that line. So suppose if the slope and x-intercept is given, see, before that I tell you one thing. So one point and slope of the line are given. Slope of the line and one of the point on the line are given, x1, y1. In such case, you would have to apply this point slope form, y minus y1 equal to m into x minus x1, and simplify, you will get that line equation. This is known as point slope form of a straight line. Next, x-intercept and slope of the line are given. Then in such case, how do you find this line equation? This is the line. So this is origin and whose x-intercept is given and whose slope is given. Now this point coordinates a, 0. If the distance is a, then this point coordinates are a, 0. You know. Now point is given, slope is given. Now apply the point slope form. Y minus y1 is 0. Slope is m, x minus x1. Then this line equation will become y equal to m into x minus a. So this is the equation of this line. So if 2 points on the line are given, how do you find that line equation? So use this formula. 2 points on the line are given. Let us say one point coordinates as a x1, y1, other point coordinates b x2, y2, and find the equation of that line. So in such case, we are going to use this formula, y minus y1, which is equal to y2 minus y1 by x2 minus x1 into x minus x1. So this is called 2 points form of a straight line. Substitute the 2 points in the place of x1, y1 and x2, y2 and simplify, so that you will get your required line equation. See, next, intercept form of a straight line. X, x dash, y, y dash. One line is moving like this. This is origin. It is intersecting x axis at A, y axis at B. So this is the x-intercept made by that line. This is the y-intercept made by that line. So now tell me this line equation. X by A plus y by B, which is equal to 1. Okay, students. So if A is positive, B is positive, you get the line like this. If A is negative, B is positive, you get that line like this. If A, B, both intercepts are negative, you get the diagram like this. If A is positive, B is negative, you get the diagram like this. Okay. So this is known as intercept form of a straight line. Okay, students. Right. Next, see, y minus y1, which is equal to m into x minus x1. What is this? Equation of a line passing through a point on the line is given as x1 comma y1 and whose slope is given. So sometimes instead of slope they may give you inclination. If inclination is given, then what is slope? M equal to tan theta. Now x minus x1. Now this tan you can write as sin by cos. Sin theta by cos theta, x minus x1. So bring sin theta to the left side. Y minus y1 by sin theta. So which is equal to x minus x1 by cos theta. Okay students. So this is known as symmetric form of a straight line. What it is? Symmetric form of a straight line. I hope you have understood. But here theta should not be 0 and theta should not be 90. Okay, this line should not be horizontal, should not be vertical. In such case you can apply this formula. Okay student, this is known as symmetric form of a straight line. When you have to apply to find the equation of the line, whenever the inclination and point is given. Otherwise, prepare the slope separately, m equal to tan theta, and substitute in this. And from this only we are going to get parametric equations of a point on the line. So for that you need to consider this one equal to some r and equate these two. Okay students. So on equating these two, I will get x equal to x1 plus, here I would like to write mod r sin theta, cos theta. On equating these two, I will get y equal to y1 plus mod r sin theta. These are known as parametric equations of a point lying on this line where theta is the inclination of that line. Okay students. So where do we use this parametric equations of a point? You may ask me. See, you get this kind of questions students based on that xx dash y dash. One line is there. On the line there is one point, fixed point A, whose coordinates are x1 comma y1 and whose inclination is given as theta, and they will ask us to find a point which maintains r distance from A on this line. On the line there are infinitely many points. Find a point on this line such that the distance from A to that point is r units. Means that r units may be above the A or below the A, no? So our required point P you may get over here or you may get here. So the distance from P to A is r units, A to Q also r units. So in such case you have to use these parametric equations. If you remove this modulus symbol, you have to write plus or minus, you know. So when you take plus, you get these P coordinates. Here if you treat minus, you get Q coordinates. I hope you have understood the purpose of this parametric equations of a point on the line. Fixed point is given, inclination is given, and asking us to find a point on same line which maintains a distance r units from the fixed point. So if you treat plus, you get P coordinates. If you treat here minus, you get Q coordinates. You have to remove modulus symbol. Whenever you remove the modulus symbol, you have to write there plus or minus. You know that. Okay students? Right. Next let us go to the normal form of a straight line. Normal form of a straight line. You know students, see, there is a one line which is moving P units away from the origin. How much far away from origin? P units. Means perpendicular distance from origin to this line is P. and this perpendicular is making an inclination alpha with x-axis. Okay, then the equation of this line in terms of alpha and p is x cos alpha plus y sin alpha, which is equal to p, where p is the perpendicular distance, hence it should be always positive. Observe that. So this is known as normal form of the straight line. X cos alpha plus y sin alpha equal to p, where interval for alpha is 0 less than or alpha less than 2 pi. So you can rotate this line like this. If you rotate, then this alpha can take angles from 0 to 2 pi. 2 pi not included, 0 is included. Okay students, one Cartesian form of a line will be given to you and they will ask you to convert into the normal form. Okay, you know that procedure. You have to make that C as positive, that has to be transported to the right side of the equal, and you have to make positive, then you have to divide both sides with root a square plus b square, then you have to transform that equation into this form, x cos alpha plus y sin alpha equal to p. So that kind of questions are expected in the competitive exam. If you want, I can show you very small application. See here, x plus y plus 1 equal to 0. This is a Cartesian form of a straight line and asking us to convert into the normal form. Then what do? So this constant has to be transported to the right side. Now I have shifted. Now we have to make RHS as positive. Multiply both sides with minus. Minus x minus y, which is equal to 1. Now divide both sides with root a square plus b square. Here a is 1, b is 1. So root 2 you will get. Now here it is minus 1 by root 2. So that I am going to write as cos 225 degrees. And here minus 1 by root 2. That I am going to write as y sin 225 degrees. So which is equal to 1 by root 2. So now we have transformed this Cartesian form into the normal form. See here, x cos alpha plus y sin alpha equal to p. Why I wrote 225 degrees? Error. In the place of cos alpha, sin alpha, both you have got negative. Cos, sin, both are negative in third quadrant. In the third quadrant, at which angle? So this will be minus 1 by 2, minus 1 by root 2, minus 1 by root 2 at 225 degrees. Okay students, I hope you have understood this normal form of a straight line. Yes. Now let us go to the position of a point with respect to the line. Position of 2 points with respect to the line, students. See here, 2 points are given. A coordinates x1 comma y1, B coordinates x2 comma y2. Now connect to both of them. You got a straight line. Okay. Now there is a one line whose equation is ax plus by plus c, which is equal to 0. Now at what ratio this line divides the line joining of AB? I want PA by PB. At what ratio this line divides the line joining of AB? So this is the point of division, which means that PA by PB. Let us take this ratio is m is to n. Then you get this ratio by this formula, minus of ax1 plus by1 plus c by ax2 plus by2 plus, so this is c only. Yes. If you substitute this point in the left side of this equation, so that is denoted by minus L11. Remember this notation. If you substitute this second point in the left side of this equation, that is denoted by L22 minus L11 by L22. Okay, at what ratio? This line divides the line joining of AB minus L11 by L22. You know the meaning of L11, L22. Simply this point you have to substitute in the place of x and y in the given equation. That is L11. And if you substitute second point in the place of x and y, that is L22. Okay, minus L11 by L22. If these 2 points are either side of this line, then you get this ratio is negative, students. Okay, see, whenever, see, otherwise you remember like this, students. If L11, L22 both gets the same sign, okay, if both gets the same sign, then the 2 points will be lying same side, okay. So if both are positive, here positive by positive, and before that minus is there, ratio will be negative. So here negative by negative, which becomes positive, ratio is negative. But here simply you remember like this, whenever L11, L22 both may be positive, both may be negative, then you can say that points belongs to the same side. Either those may be either this side or this side. However it can be, but exact diagram we cannot draw. Just we people are commenting on the 2 points with respect to the given line, whether those are lying same side or either side. So if both gets the same sign, then the 2 points are lying same side of the straight line. If L11 is positive, then L22 is negative, or L11 is negative, L22 positive, then what do you comment? So that the 2 points are lying either side of the straight line. Okay, L11 is positive, L22 is negative. Otherwise L11 is negative, L22 is positive, then 2 points will be either side of the line. If one point is this side and other point should be this side. Okay, so this is the position of 2 points with respect to the given line. Okay, students. Now let us go to the distances. Okay, so one line equation will be given to you, students, like this, whose equation is ax plus by plus c equal to 0, and a point will be given to you. Okay, and we need to find a perpendicular distance from this point to this line, because from this given point to given line you can draw many more distances. Among all that, this is the perpendicular distance. So that you are going to get by applying this formula, mod of ax1 plus by1 plus c by root a square plus b square. So here I used the mod because distance will never be negative, absolute value. You have to take this as positive. Sometimes while simplifying, inside you may get negative, even though it should be treated as positive. So distance, write their units. Perpendicular distance from the given point to the given line. So suppose if it is origin, now replace x1 y1 by this origin, so that you will get that perpendicular distance mod c by root a square plus b square. Okay, students, right. So sometimes, see, x dash, y dash, there is one line whose equation is ax plus by plus c equal to 0, and one more line is given like this. On the line there is one point P whose coordinates are x1 comma, otherwise let it be capital A, fixed point. Now in the previous one, we calculated a perpendicular distance from x1 comma y1 to the line, shortest distance. But here this is not perpendicular distance. We are measuring the distance from this point to this line along with this line, which is making an inclination theta. So I want this distance r. Measure a distance from A to this line along with this line, which makes an inclination theta. Okay, so this is not perpendicular distance, it may be, but we are measuring this distance along with this line from this point to this point. Find a distance from this point to this line measured along with a line making an inclination theta. Very easy, students. See, just now we learned parametric equations of a point on the line. So let us take this point. This is the common point of this line as well as this line. Now this point P is there. How much far away from this given point? R units. Then what are the coordinates of P? x1 plus r cos theta and y1 plus r sin theta. Okay, this is rough diagram, students. As I said to you, if P is above the A, I said to you take this is positive. If it is below, minus. But I took there positive. Now this point P is there on this line also, no? Hence I am replacing x by this, y by this. So A into x1 plus r cos theta plus b into y1 plus r sin theta plus c, which is equal to 0. Now simplify, students. On the simplification you get, so here r into a cos theta plus b sin theta. Now send all of them to right side. So minus ax1 minus by1 minus c. I want this r. Now send this one to the right side. Minus of ax1 plus by1 plus c by a cos theta plus b sin theta. But this is a distance. It never been negative. Hence I am going to apply mod. So that you get mod of ax1 plus by1 plus c by a cos theta plus b sin theta. So this is the required distance from A to this line. So suppose if it is origin x1 y1. Now put x1 y1 as a 0 comma 0. Hence you will get r equal to mod c by a cos theta plus b sin theta. Okay, students. I hope you have understood this. Now let us go to find distance between the parallel lines. Distance between the parallel lines. Two lines are given like this, whose equations are ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0. These are the parallel lines. We want the shortest distance between these two parallel lines. So use this formula, students. Mod of c2 minus c1 by root a square plus b square. So this is the distance between the parallel lines. Okay, I hope you have understood this. And sometimes, so this distance also they may ask you. Two parallel lines will be given to you. See, like this. Now in the earlier one, we prepared the shortest distance between the two lines. But now I am measuring the distance along with this line, which is making an inclination theta. Means I want this. This is not shortest distance between these two. So here we are measuring this distance, okay, which is along with this line, making an inclination theta. So this I want r. Now r equal to, so same like previous one, c2 minus c1 by, in the denominator, a cos theta plus b sin theta you will get. Okay, you get the inclination from here and substitute here. A and B you will get from the line equations. So this is Ax plus By plus C1 equal to 0. This is Ax plus By plus C2 equal to 0. For the parallel lines, we get the difference in the constant places only. You know that. Right, students? Next, here, okay, two line equations are given. Ax plus By plus C1 equal to 0 and one more Ax plus By plus C2 equal to 0. Now I want, so this line which is exactly middle of both and it is parallel to both of them. So this is the equation. Here we are going to find equation of this dotted line which maintains same distance from this line and this line. Both are parallel. These three are parallel. Then equation of this dotted line is Ax plus By plus C1 plus C2 by 2 which is equal to 0. So this is the equation of a line which is parallel to the two given lines and which maintains the same distance. So this length is equal to this length. What is its equation? Ax plus By plus C1 plus C2 by 2 which is equal to 0. Remember that. And sometimes students, see, one line equation will be given to you. Ax plus By plus C equal to 0. And they will ask you to find equation of a line which maintains d units away from this line and that line must be parallel to the given line. We want these two line equations. In the previous one, these two are given. We calculated that middle line equation which is exactly middle of both and that should be parallel to the given lines. Here only this line is given and asking us to find these two which maintains the same distance dd. Reverse to the previous one. So apply this formula. Ax plus By plus or minus d into root a square plus b square which is equal to 0. If you take plus, you get one line equation. If you take minus, you get one line equation. So these are rough diagrams. Okay students. So how do you get these two required line equations? By applying this formula. Ax plus By plus or minus d into root a square plus b square is equal to 0. Okay. Right. Now I am going into put of the perpendicular. One line, one point is given and they will ask us to find whose put on that line. Okay. One line is given. Ax plus By plus C equal to 0. And here one point is given whose coordinates are x1 comma and y1. And drop a perpendicular on this line. Perpendicular. So this is called put of P with respect to this line. So this you would have to find, let us say, whose coordinates are h comma k. Then coordinates of Q are h minus x1 by a which is equal to k minus y1 by b which is equal to minus of ax1 plus by1 plus c by a square plus b square. Now collect this a, b, c and x1, y1 from there and substitute in this and equate these two so that you will get h comma k. This is the way to find put of this point with respect to this line. Observe that this point should not be lying on this line. Okay? Right. Next, image of this point with respect to this line. Where do you get image? This is like mirror. You know, daily we see our face in the mirror. Where do you get your image? The distance from point to this line is equal to line to image. This is image. Let us say whose coordinates are h comma k. Now how do we find q coordinates? By this formula, h minus x1 by a, which is equal to k minus y1 by b, which is equal to minus 2 of ax1 plus by1 plus c by a square plus b square. So same like put of the perpendicular only, but here minus 2 you will get. So collect this x1 y1 and abc from there and substitute in this and equate these two, you get h. Equate these two, you get k. So those are our required image coordinates of P with respect to this line. And here we have some properties. Okay students, one point will be given to you. Okay, see here there is a one line. See here x1 comma y1 are the coordinates of A, and here P will be given like alpha comma beta. Now what is the image of this point in this point? Image of this point in this point. So this is the image na. Let us say this is B. So let us consider image coordinates h comma k. Now okay, we want to calculate h comma k. How do you find? For these 2 points and P be the midpoint. Now we equate. So h plus x1 by 2 if you do, you will get alpha. And k plus y1 by 2, you will get beta. So here h how do you get? 2 alpha minus x1. K how do you get? 2 beta minus y1. So h comma k you have got. This is the way to find image of one point in another point. Okay students? Right. Next. See, there is a one point in the first quadrant. See, let us take this point coordinates as 2, 3. So this is x-axis. This is y-axis. What is the image of 2 in x-axis? In the fourth quadrant you get, in the fourth quadrant. So x is positive, y is negative, 2 comma minus 3. What is the image of 2 in y quadrant, y-axis? Minus 2 comma 3. What is the image of 2 in origin? Here you will get minus 2 comma minus 3. Not only this students, but also if any curve equation is given, okay, curve equation will be given to you like this, f of x comma y, curve equation, okay, second degree equation which represents, okay, graph of a curve. One curve equation will be given to you and they will ask you what is the image of that curve in x-axis. In x-axis means what you have to change? Y coordinate. So x comma minus y. This is the image of this curve with respect to x-axis. What is the image of this curve with respect to y-axis? F of minus x comma y. Okay students, that may be curve or a line. See, you know y equal to x line, x dash, y dash. So what is this? A line y equal to x. What is the image of alpha comma beta with respect to this line? Just this coordinates will get interchange, beta comma alpha. Image of alpha comma beta with respect to y equal to x line is beta comma alpha. So this is one more line which is equally inclined with coordinate axis whose equation is y equal to minus x, or if you bring x to the left side, x plus y equal to 0. The image of this alpha comma beta with respect to this line, here somewhere you will get. So both you have to interchange and you have to put opposite sign, minus beta minus alpha. Okay students? So with respect to this line, so this is equal inclined with x-axis and y-axis, angular bisector for the first and third quadrants. So image of alpha comma beta with respect to this line is beta comma alpha you will get, and with respect to y equal to minus x will be just you have to interchange and put opposite side. Okay students, right. Next, one more important point from this properties of images. See, one line equation will be given to you like this, like you can take it as Lx plus My plus n equal to 0, and one more line is moving like this, Ax plus By plus C equal to 0. I want the equation of this image of this line with respect to this line. What I want? Image of this line with respect to this line. Means, so you get the image like this. Whose equation you have to find? I give you the shortcut, but you can do the regular procedure also. The shortcut is L square plus M square into, so you have to write this line here, Ax plus By plus C, so which is equal to 2 into this Al multiply, Al here Bm into again write this line, Lx plus My plus N. If you simplify this, you will get this dotted line equation. So that is the image of this line with respect to this line. Many ways are there to find this dotted line equation. So these three are concurrent at this point. If you solve these two, you get this point. This point you will get, and identify a point on this and get whose image in this. Here you will get that image. After getting these 2 points, apply the 2 points form of a line equation so that you will get this image equation. Okay students? See, otherwise you better to do like this. Remember, like a standard result. Here L M you get from here L square plus M square into, write this complete left side of equal here is equal to 2 into here Al plus Bm into this. You get this line equation. I hope you have understood this. Now let us go to discuss intersecting lines. Intersecting lines. 2 lines are given like this. A1x plus B1y plus C1 equal to 0 and A2x plus B2y plus C2 equal to 0. So you know, okay, here these two are intersecting lines. How to find this point of intersection, you know, solve both of them. To solve the linear equations in 2 variables, there you have many methods like elimination, substitution, cross multiplication method. But in the IIT track, we solve them by method of cross multiplication. You know that. Apply that and get this point of intersection. Okay. And also you know students, unless the 2 lines are 90 degrees to each other, so they intersect like this, means one pair of opposite angles are acute angles and one more pair is obtuse angles. So if it is theta, then this angle will be 180 degree minus theta. So you know how to find angle between the 2 lines. So you better to apply this formula, cos theta, which is equal to mod of A1 A2 plus B1 B2 by root of A1 square plus B1 square into root of A2 square plus B2 square. Apply this formula so that you will get angle between them. Either they may give you acute angle or obtuse angle in the options. Both are correct only. Here if I keep here modulus symbol, you will get acute angle. So suppose if it is 30, then this can be 150. So both are correct only. Otherwise, you can use this formula, tan theta is equal to mod of m1 minus m2 by 1 plus m1 into m2. Use this formula. So m1 represents the slope of this line. When the line equation is given like this, how to find whose slope you know. Minus a1 by b1. So second line slope m2 minus a2 by b2. You got both slopes and substitute here so that you will get angle between them. Either use this formula or this formula. If the lines are parallel, then you will get a1 by a2 which is equal to b1 by b2 is equal to c1 by c2, but not equal to c1 by c2. Parallel. So whose slopes are equal? You know. Okay students, if both are coincident, then a1 by a2 equal to b1 by b2 equal to c1 by c2. If both are 90 degrees to each other, put theta here. So cos 90 0, bring it to the left side. 0 into something 0. a1 a2 plus b1 b2 is equal to 0 you will get. And here also. So if the two lines are perpendicular, m1 into m2 equal to minus 1, you know. So like this you people have to find angle between the two given lines, two given intersecting lines. Okay students. And so sometimes, see students, one line equation is given and whose slope is given as alpha, not whose slope is given as m, and the two lines are moving like this and which are making same inclination with this given line. It is a given line whose slope is m, and the two lines are moving like this and which are making same inclinations with the given line, and they will ask you to find this line's slopes. Okay, so now I am considering this line slope is m1. Now apply the tan theta between this. So tan of alpha is equal to, so mod of, what do you get students? m1 minus m by 1 plus m1 m. If you remove the modular symbol here, you have to take plus or minus. m1 minus m by 1 plus m1 into m, which is equal to plus or minus tan alpha. Now once you take plus m1 minus m by 1 plus m1 m, which is equal to tan alpha. Now take cross multiplication so that you will get m1 minus m. So here tan alpha plus m1 m tan alpha. So here we need to find m1 now, make m1 subject. So transfer this 1 to the left side and so that take m1 common. So you get 1 minus m tan alpha. So send it to the right side, m plus tan alpha. Now you want m1. So send it to the right side so that you will get this line slope m1 is equal to, so m plus tan alpha whole by 1 minus m tan alpha. Okay students. So slope of this line is given and these two lines are making same angles with this given line and asking us to find these two line slopes. So I took these two line slopes as m1. So angle between these two. So here I applied tan alpha which is equal to m1 minus m by 1 plus m1 m. I removed the modular symbol. I have taken plus or minus. I equated plus. I got m1. So that may be slope of this line. So here if I equate minus and here put minus and simplify. Okay. So if I put here a minus, what I will get? So if I take here minus, here it is minus. Now simplify. m1 minus m. So minus tan alpha minus m1 m tan alpha. So bring it to the left side so that you will get m1 1 plus m tan alpha. Send it to the right side. m minus tan alpha. Now I want m1. Now m1 is equal to m minus tan alpha by 1 plus m tan alpha. Okay students. Same thing you have got, but here minus, here plus. So if it represents slope of this, then this represents slope of this. Okay students, I hope you have understood this. Right, next. Okay, see students, two lines are intersecting like this. You know, this is whose angular bisector, and for this angular bisectors I taught in my previous classes. So once go through my previous classes, which you will find in my playlist classes, go to the coordinate geometry and search in that. You will get that angular bisector class. There you will get more knowledge from this angular bisector. Okay students, I gave you complete concept of angular bisectors in that. Now here in this, I don't want to discuss about that angular bisectors concept. So but here, this is the angular bisector whose slope is m, and two given lines slopes are m1, m2. Then you know this angle is equal to this angle, because angular bisector divide this angle into two equal halves. You know that. Now if you apply tan alpha between this and this, you get m minus m1 by 1 plus m1. And for these two, tan alpha is equal to mod of m minus m2 by 1 plus m2. Both are equal. Now you can equate both of them. So m minus m1 by 1 plus m1, which is equal to plus or minus m minus m2 by 1 plus m2. Okay students, when you remove modulus symbol on both sides, you have to take plus or minus. So remember this while doing the applications, so it may help you. Okay students, right. Next, I am going to discuss with you concurrent lines. Concurrent lines students, concurrent lines. Okay, you know, three line equations are given. a1x plus b1y plus e1 equal to 0, and a2x plus b2y plus e2 equal to 0, and a3x plus b3y plus c3 equal to 0. Concurrent means three or more than three lines passes through the same point, then that lines will be called concurrent lines. If these three are concurrent, you know students, the determinant which forms by whose coefficients a1, b1, c1, a2, b2, c2, a3, b3, c3, which is equal to 0. If these three are concurrent, the determinant which forms by these coefficients 3 by 3 det which forms by these coefficients is equal to 0. Very easy and important. Sometimes they will ask you this point of intersection. Just solve any two of these three so that you will get this point of intersection. Okay, and take any three real numbers like lambda. So let it be L1, let it be L2, this is L3. So lambda into L1, lambda 1 L1, lambda 2 L2, lambda 3 L3, which is equal to 0 you will get if these three are concurrent. Where lambda 1, lambda 2, lambda 3 are parameters, means which belongs to any real numbers. For any three real numbers, so this sum would be equal to 0. Okay, right. Next students, so from these concurrent lines, see here, this type of question is very very important. One point is given like x1 comma y1, and here some group of points are there. So this is P, and they will ask you, okay, so what is the line which belonging to this concurrent line which maintains a maximum distance from A. Okay, find a line which belongs to this family. Okay, here many lines are there. Family of lines L1 plus lambda L2 which is equal to 0. Lambda is a parameter. L1, L2 are any two line equations which belongs to this family. So this is the standard form of concurrent lines or family of lines. Now I want a line which is maximum distance from A. Means, see here, you have to connect this A and P, students. And the line which passes through P and perpendicular to this AP is the required line equation. This perpendicular one to AP and passes through P is the required line which is maximum distance from A. This is one model of question. And so they will give you a fixed point A and they will ask us to find a line equation which belongs to this family and which maintains a d units away from A. That d units either it may be from this side or this side. Two such lines will be possible. Okay, let us take this is B. Okay, students. So whenever AB is more than D, then only these two lines are possible. When AB is less than D, so such lines will not be existed. Remember that point. The distance from A to B, this distance E, is more than D, then two such lines are possible, which maintains a distance D units from A. If AB is smaller than D, then such lines will not be existed. So this point is also very, very important. And one point and family will be given to you. And they will ask you to find a line which maintains a D units from A. Okay, this question is very, very important. Two lines will be possible. If lines are existed, two are possible. So this kind of applications you get in the competitive exams from these concurrent lines. Next, students, let us go to discuss this triangles and quadrilaterals which are connected with these lines. You know, students, triangle whose side equations will be given to you. A1x plus B1y plus C1 equal to 0 and A2x plus B2y plus C2 equal to 0 and A3x plus B3y plus C3 equal to 0. And they will ask you to find what kind of triangle is this. Means whether it is right angle triangle or equilateral triangle, this kind of options will be given to you. But generally what do we do? Your side equations are given, vertices are not given. General procedure, solve these two you get A, solve these two you get B, solve these two you get C. After getting ABC vertices, then find the distance between AB, BC, CA. If you know the lengths of sides of the triangle, then you can comment on the triangle. What kind of triangle is this? Okay, students. So instead of doing like this, so you measure this ratio. Root of A1 square plus B1 square, put here mod. So here A1, B1 we used now. So here you take A2, B2, A3, B3 is 2. Here A2 square plus B2 square. Here you write A2, here A3, B3, A1, B1 is 2. Root of A3 square plus B3 square, determinant here A1, B1, A2, B2. I think I hope you have understood. Remember this. So this is 1, 2, 3 terms. Between them ratio is there. Find this ratio. Collect A1, B1, A2, B2, A3, B3 and substitute in this. So here this is 2 by 2 det. You know how to find a 2 by 2 det. AD minus BC. ABCD, AD minus BC. So measure this ratio. Suppose if you get a ratio is 1:1 root 2, then that is right angle isosceles triangle, because inside angles will be 45, 45, 90 you will get. So two angles are equal, isosceles. One angle is 90, hence it is right angle isosceles triangle. You know, if angles ratio are 1:2, then corresponding sides ratio will be 1:1 root 2. Hence, if you find the sides ratio 1:1 root 2, then what do you comment? That is right angle isosceles triangle. So if all the sides ratio is 1:1, then that is an equilateral triangle. If the sides ratio is 1:root 3:2, if this ratio, if you get this much, then angles will be 30, 60, 90. Hence that is only right angle triangle. Okay, prepare this sides ratio. Then if you get 1:root 3:2, then what do you comment? That is right angle triangle. Suppose if you get 1:1 root 2, right angle isosceles triangle. If you get 1:1, equilateral triangle. And sometimes they will ask you to find this triangle area. So if you know the vertices, you know how to find area of the triangle. But if you do not know the vertices, then find the vertices and then find whose area. You can do like that. But here some shortcut is there. So you can utilize that to find the area of the triangle delta equal to, okay students, lambda, okay. See, there is one det, area of the triangle, right? Delta square by 2 into mod of lambda 1 into lambda 2 into lambda 3. Okay students, what is delta here? 3 by 3 det which forms by these three vertices. Okay, so here A1, B1, C1, A2, B2, C2, A3, B3, C3. So find the delta of this 3 by 3 which forms by coefficients and substitute here. You may ask me what is deltas are. Okay students, I will give you clarity for this delta. Lambda 1, lambda 2, lambda 3. Lambda 1, lambda 2, lambda 3. Yes. See students, lambda 1 means here. Same like previous one. Lambda 1 means the det of A2, B2, A3, B3. Lambda 2, det of A3, B3, A1, B1. Lambda 3. So A1, B1, A2, B2. So get that lambda 1, lambda 2, lambda 3 and substitute here. 2 by 2 det forms by this. Lambda 1, lambda 2, lambda 3. Collect from there and substitute here. And simplify, you will get area of the triangle. Okay students. So sometimes equations of sides of a triangle will be given like this. So find the equation of find the area of a triangle whose side equations are given like this. ABC. Y is equal to m1x plus c1. Y equal to m2x plus c2. Y equal to m3x plus c3. Slope and y-intercept form is given. Side equations are given in slope and y-intercept form and asking us to find whose area. Here also identify the vertices, then apply that area of triangle formula which you learnt in the coordinate geometry. Otherwise, you can use this formula. Delta is equal to 1 by 2 sigma C1 minus C2 whole square by M1 minus M2 modulus closed. You know meaning of sigma. Okay students, in the next one, possibility C2 minus C3 whole square by M1 minus M2 plus next C3 minus C1 by M3 minus M1, cyclic order. So that I kept here modulus symbol. Area now you have to write with square units. Okay students, I hope you have understood this. Right. Now, here what did we learn in these triangles? Okay, equations of sides of the triangle are given. Then how to identify what kind of triangle is this and how to find whose area. Next, let us go to the quadrilateral. Okay, parallelogram. So in the parallelogram, see students, actually four equations will be given to you like this. Ax plus by plus c1 equal to 0, ax plus by plus c2 equal to 0. These are two parallel lines. And here one more pair of parallel lines, px plus qy. Here you can take m, and px plus qy, n is equal to 0. So this is one more pair of parallel lines. And they will ask you what kind of quadrilateral is this. Okay, it is a parallelogram, but what kind of parallelogram? You know types of parallelograms. Simply whether it is parallelogram or it is square or rhombus or rectangle. So this kind of options will be given to you, and side equations will be given to you like this. These represents equations of sides of a parallelogram, not parallelogram, quadrilateral and mention chestadu. And they will ask us to find what kind of quadrilateral is this. Okay students, so what do? You would have to find slope of this. What is the slope of this? M is equal to minus a by b. What is the slope of this? Let it be m1. What is the slope of this? m2 minus p by q. If you take the product of these two, if m1 into m2 equal to minus 1, then either that may be a square or rectangle. This is square and this is rectangle. Okay students, if m1 m2 is not equal to minus 1, then either that may be a simply parallelogram or a rhombus. So to get more clarity, you have to measure the distance between them. This is d1, d2. So in the case of square, d1 equal to d2. In the case of rectangle, d1 is not equal to d2 you will get. In the case of parallelogram, d1 is not equal to d2. But in the case of rhombus, you will get d1 equal to d2. Okay students? See, m1, m2, m2 equal to minus 1. Then don't comment as a square. Either it may be square or rectangle. You have to check this distance between the parallel sides. If it is equal and m1, m2 equal to minus 1, then that is square. If m1, m2 equal to minus 1, d1 is not equal to d2, rectangle. If m1, m2 equal to not equal to minus 1, d1 is not equal to d2, that is parallelogram. If m1 into m2 equal to is not equal to minus 1 and d1 equal to d2, that is rhombus. Like this you have to classify what kind of quadrilateral is this whenever you find the equations of sides of a quadrilateral like that. Okay students, and sometimes they will ask you whose area also. Whose area? area of this quadrilateral you get like this. Take the difference of these two, C2 minus C1 into difference of these two, M minus M1, M minus N, whole by, so here A square plus B square, so in the denominator you get like this, students. See here, area of the quadrilateral which forms by the side equations. So here A1, here modulus only, A into Q minus B into P square units. Okay, students, how do you find area of this quadrilateral? If it is parallelogram or rhombus or rectangle or square, just take the difference of these constants into, take the difference of this constant by A into Q minus this B into P square units. Okay, students, right. Next, students, see here two parallel lines and one intersecting line are given. How many circles can be drawn to this system which touches three lines? Two parallel lines, one intersecting line is given. Now how many circles can be drawn to this system which touches three lines? So one is here and one more is here. Two such circles can be drawn to the three lines which touches three line equations. Okay, students, right. If these three lines are concurrent, so here this is point circle, only one can be drawn, that is point circle which touches three lines. If three are parallel, no circle can be drawn. You have to draw a circle which touches the three lines. So here two, in this case two possible. If the lines are concurrent, only one is possible, that is point circle. Don't get confusion here. Here it is possible, that is point circle means negligible radius. So here no such circle is possible which touches three lines. So one more possibility, no two are parallel. Among the three lines, no two are parallel means you get the diagram like this. So in this case, four circles are possible. One is inside and three more are X circles, because here, okay, see, if no two are parallel means you get a triangle here. So one is in circle and three are X circles. Totally four circles can be drawn to these three lines if no two are parallel. One is in circle, three are X circles. Four such circles are possible. Remember this point also. Next, students, you know how to find orthocenter and circumcenter and incenter of a triangle formed by so and so vertices. Vertices of the triangle are given, and how to find incenter, you know, students. Incenter of a triangle formed by the vertices A, x1 comma y1, B, x2 comma y2, C, x3 comma y3. Vertices of the triangle are given and asking us to find incenter. Find the length of BC, small a, length of AC, small b, length of AB, small c, and substitute in this formula. ax1 plus by1 plus cz1 by a plus b plus c, comma ay1 plus by2 c y3 by a plus b plus c. You get in center of this triangle which forms by interior concurrent of interior angle bisectors. You have studied in the introduction of coordinate geometry. So in center coordinates you get by this formula where ABC represents lengths of BC, AC and AB. Whenever the vertices are given, how to find A, B, C you know, and substitute here so that you will get I. And how do you find orthocenter? Orthocenter is the point of intersection of perpendicular bisectors of sides. So which is equidistant from all the vertices. SA is equal to SB equal to SC. So when you know the interior angles, so you can find this circumcenter. Circumcenter, point of intersection of perpendicular bisectors of sides of a triangle is called circumcenter. So you have one formula that is applicable whenever the interior angles are known to us. If interior angles are do not know, then you have to find any two perpendicular bisectors of sides. You know how to find perpendicular bisectors of sides. Get any two and solve them so that you will get S. Okay students, otherwise so you can take that circumcenter as alpha comma beta and equate these three and go for simplification so that you will get the circumcenter. You would have to consider circumcenter as alpha comma beta and apply this step because vertices are given, and use this concept and get alpha comma beta. That is one way to find circumcenter. Otherwise when you know the interior angles, so you can apply this formula S1 into sin 2a, x2 into sin 2b, x3 into sin 2c whole by sin 2a plus sin 2b plus sin 2c. Okay, right. In the same manner, y coordinate y1 into sin 2a, y2 into sin 2b, y3 into sin 2c whole by sin 2a plus sin 2b plus sin 2c. So this is one formula which you have to find circumcenter of the triangle when the vertices are given. But this is applicable whenever the interior angles of the triangle are known. But sometimes in the standard problems they will ask you like a formula. You better to remember this. Now let us go to find orthocenter of the triangle. Orthocenter means which is the point of intersection of altitudes of a triangle. Vertices of the triangle will be given to you and get any two altitude equations and solve them. You will get orthocenter which is denoted by the letter H or O. Okay. So here we have one formula x1 into tan A and x2 into tan B and x3 into tan C by tan A plus tan B plus tan C, comma y1 into tan A plus y2 into tan B plus y3 into tan C whole by tan A plus tan B plus tan C. You can use this formula to find orthocenter of this triangle, but when it is applicable whenever the interior angles are known to you. Okay, if you do not know, even though you can find interior angles by the properties of triangles concept, but in the coordinate geometry just you better to identify the any two altitude equations. How to get the altitude equation you know. Prepare those equations and solve them so that you will get orthocenter. You know students, so properties of location of orthocenter, location of circumcenter for various triangles we have discussed in the introduction of coordinate geometry. So for acute angle triangle, circumcenter you will get inside. for right angle triangle on the midpoint of hypotenuse. This is very, very important. Okay. So for right angle triangle, where do you get orthocenter? At the vertex where the right angle is located. So these two are important. Location of circumcenter and orthocenter for right angle triangle. For circumcenter, for the right angle triangle, you get midpoint of hypotenuse. Orthocenter for the right angle triangle, where do you get? At a vertex where the right angle is located. Okay, students? And you know the Euler line. Euler line. So that is also very important. So, you know, students, see here. This is orthocenter. This is centroid. This is circumcenter. So except for the right angle, except for an equilateral triangle, for all other triangles, this OGS are collinear. O means orthocenter, G means centroid, S means circumcenter. Orthocenter, centroid, circumcenter are collinear. The line which passes through these 3 points of a triangle is known as Euler line. But what is the condition? That a triangle should not be an equilateral triangle. For an equilateral triangle, all will be coincident. So this G divides OS in the ratio of 2:1. 2:1. Based on this, they will generate the application. Very, very important in competitive exams. Euler line. Next, students, here you would have to remember one more point, optimization applications. See, there is one line ax plus by plus c equal to 0 and 2 points are given, A and B. And they will ask you to find a point on this line such that PA plus PB is minimum. To get this result PA plus PB minimum, so you have to identify a point on this line. Where is that point? Because on this line there are infinitely many points. How do you find that point P? That is the question. Okay, students? See, in this type of models, you would have to find image of either A or B in this line. Shall I find image of A in this line? You may get here A dash. How to find image of A in this line? You know. Apply that image theorem and so that you will get image of A in this line, that is A dash. And connect this A dash B. Now prepare this A dash B line equation because 2 points are known to us. Then get whose line equation and it is given. Solve both of them, that is our required point P. Under this optimization, 2 models are there. One is PA plus PB is minimum and one more is, see, PA minus PB. PA minus PB. Put here mod symbol. So this difference is maximum. So in this case, students, so here this is a given line equation ax plus by plus c equal to 0. Here 2 points are given. Mostly these 2 points will be given to you same side of the line. You know how to check whether the 2 points are lying same side or not. You know that S11 concept, S22 concept, both gets the same side. So now connect these two and extend it. Get the equation of this line. 2 points are given. How to find this AB equation? You know. So prepare that AB equation. Already it is given. Solve both of them. So this point of intersection of AB and this line will be our required point P, such that PA minus PB is maximum. Here in this case you have to find image of either A or B. I prepared A image. I prepared A dash B equation. And I solved these two, I got P. So these are optimization models of applications. And students, so one more point is left, that is last in this chapter, reflection models. you know, you get in the physics. So one line equation will be given to you. Ax plus by plus c equal to 0. On this line, one light ray is heating. Here it is coincident. Again, it gets reflection in this side. This is incident ray. Incident ray. And this is reflected ray. Reflected ray. So this is the normal. You know. This is angle of incident. This is angle of reflection. Both are equal. Angle I is equal to angle R. So use this concept. So sometimes this equation and this equation will be given to you and reflected ray equation will be asked to you. Sometimes reflected ray and this will be given to you. Equation of incident ray they will ask you. So this kind of questions can be expected from this reflection models. Okay students, I hope you have understood. So what I taught to you in this complete class. So this is the required concept for the competitive exams like IIT mains and advanced or local level engineering entrances like EAP set or other private universities exams. I hope you can utilize this class. I am requesting you to subscribe, like and share my channel so that my classes reaches to many people. Thank you students. Thank you one and all.